Welcome all of you in this session. My name is Dr. Vishal Patil. I am working as an associate professor in Department of Mechanical Engineering. The name of the subject is thermodynamics. Today we will study the points related with the heat and work. The content for this presentation are: first one is heat, second one is sensible heat, third one is latent heat, fourth one is specific heat, fifth one is work, next heat and work as a path function, and last point it is related with the similarities between the heat and work. Second point is heat. The heat is defined as energy transfer without transfer of mass across the system because the temperature difference between the system and the surrounding. The surroundings may be real or imaginary. It is usually represented by the Q and is expressed in terms of joule or in kilojoules. The modes of heat transfers are conduction, convection, and radiation. The transfer of heat through the solid takes place by conduction, while the transfer of heat through the fluid is by convection. The radiation is the electromagnetic wave phenomena in which energy can be transferred through the transparent substance and even through the vacuum. These three modes of heat transfer are quite different, but they have one factor in common. All these modes occur across the surface area of the system because the temperature difference between system and surrounding. As as per this figure, there are three modes of heat transfer: conduction, convection, and radiation. The heat is transferred to the this vessel which having the hot fluid. The heat transfer from the fire to the surrounding, it is in the form of radiation. The heat transfer between the fluid, means in the liquid, is known as the convection, means from the body with surrounding, and conduction will occur as shown in this figure in the handle because of heat transfer between the substance, means conduction takes place due to the lattice vibration or flow of free electrons. The important points related with the heat are: first one is the heat is transferred across the boundary from the system at higher temperature system to the lower temperature system by virtue of temperature difference. Second important point is the heat is form of transit energy which can be identified only when it crosses the boundary of the system. It exists only during the transfer of energy into or out of the system. Third important point, the heat flowing into system is considered as positive and heat flowing out of the system is considered as negative. The next important point is classification of heat. The heat is mainly classified into two types. First one is sensible heat and second one is latent heat. The first part it is related with the sensible heat. The sensible heat, when a substance is heated and the temperature rises and the heat is added, the increasing heat is called as sensible heat. Similarly, when the heat is removed from the substance and the temperature falls, means the heat removed is called as sensible heat. Means addition of heat or removal of heat from the system is normally known as sensible heat. It is denoted by HF. The sensible heat may be defined as the heat which causes the change in temperature in the substance. The simple example for sensible heat is the heat absorbed in heating of water up to the boiling point is nothing but the sensible heat. The simple expression for the sensible heat is Ma into Cpm into delta T, where Ma mass of the air, Cpm humid specific heat, and delta T is nothing but the change in dry bulb temperature, means the temperature difference between the system or surrounding or in between two systems. V, it is also known as sensibility is equals to V into density into CPM into delta T in the form of kilojoule per minute. By substituting the value of density and CPM in expression, then we will get sensible heat is equals to volume into 1.2 into 1.022 into delta T. Means the sensible heat is equals to 0.02 into V into delta T. Means the sensible heat, it is related with the volume and change in temperature. Next type of heat is latent heat. All pure substances are able to change their state. The solid becomes liquid, liquid becomes gas. This change of state occurs at the temperature and pressure combination for any given conditions. It takes place the addition of heat or removal of heat to produce these changes. The heat which brings about the change of state with no change in temperature is called as latent heat. It is also known as hidden heat. It is denoted by HFG. The latent heat of ice is 335 kilojoule per kg. This means that the heat absorbed by 1 kg of ice to change into water at 0 degree Celsius and at atmospheric pressure is 335 kilojoule. This heat is called latent heat of fusion or melting of ice. The water starts vaporizing at 100 degrees Celsius, means it is a boiling point of water, and changes its state from water to steam, means converted into gaseous form. The heat absorbed during the change of state from liquid to gas is called as latent heat of vaporization or conversion of vapor to liquid. It is nothing but latent heat of condensation. The latent heat of vaporization of water at 100 degrees Celsius and at atmospheric pressure is 2257 kilojoule per kg. The expression for the latent heat is equals to mass of air into change in enthalpy. Means latent heat is equals to mass of air into HFG into delta W, where V is rate of dry air flowing in m cube per minute. Density of moist air is 1.2 kilojoule kg per m cube of dry air. HFG means latent heat of vaporization. Delta W is nothing but difference between the specific heats of system and surrounding. Then latent heat is equals to V into 1.2 into 2500 into delta W. Means latent heat is equals to 50 into V into delta W. Means the latent heat, it is related with volume and change in specific humidity. The next point is specific heat. The specific heat of substance may be defined as the amount of heat is required to raise the temperature of unit mass of any substance through 1 degree. It is generally denoted by C. In SI units, the unit of specific heat is C is taken as in kilojoule per kg Kelvin. It is also calculated by M into C into delta T. As per this figure, there are two different substances which having different specific heats. The left hand figure shows the specific heat of 1007 joule per kg Kelvin, which easily heat up, and right hand fluid which having the specific heat of 4183 joule per kg Kelvin does not heat up in small time. Means time is increases with increasing the specific heat. As per the specific heat, these are the some commonly used substance just like steel having the specific heat of 0.49, copper 0.406, glass 0.783, mercury 0.138, brick 0.837, water 4.187, ice 2.11, steam 2.04, air 1, nitrogen 1.01, oxygen 0.925 kilojoule per kg. The next point it is related with the work. In mechanism, the work defined as the product of force and distance moved in the direction of force. Means work done is equals to force into displacement. The unit of work depends upon the unit of force and distance moved. In SI unit, in practical unit of work is Newton meter. The work of 1 Newton meter is known as joule, such as 1 Newton meter is equals to 1 joule. In thermodynamics, work may be defined as per the Aubert. The work is defined as the energy transferred without the transfer of mass across the boundary of the system because of the intensive property difference other than the temperature that exists between the system and surrounding. In engineering practice, the intensive property difference is the pressure difference. The pressure difference between the system and surrounding at the surface of the system gives the gives rise to the force, and the action of this force over the distance is called as mechanical work. As per the Kinnan, the work is said to be done by system doing giving operation if the sole effect of the system on things external to the system can be reduced to the raising the weight. Means the weight may not be actually raised, but the net effect external to the system should be raising the weight of the system. The next important point it is related with the heat and work uh, path function. Consider that system from initial equilibrium state 1 and reaches final equilibrium state 2 by different two paths. Means first path it is related with 1A2 and second path it is related with the 1B2 as shown in figure. The processes are quasi-static processes, means these are the slow processes of thermodynamic equilibrium. When the system changes from the initial state 1 and final state 2, the quantities of heat transfer will depend upon the intermediate stages through which the system passes in the path. Means point number 1 it is a point function, point number 2 is a point function, and 1A2 and 1B2 these are the path functions. The heat is an inexact differential, then it is denoted by delta Q, and integration 1 to 2 delta Q is equals to Q1 to 2, means heat transfer from point 1 to 2. For the thermodynamic properties, therefore, the path function as the value depends upon the particular path followed during the process. Since the area under the path 1A2 and 1B2 are different, therefore the work done by these two processes will also differ. Hence, the work is also inexact differential of this process, then it is denoted by delta W. Then integration 1 to 2 delta W is equals to W1 to 2, means work done by path 1A2 is different than 1B2. The next important point is the similarity between heat and work. The first point is the heat and work are both transit phenomena. The system does not possesses heat or work. When system undergoes the change, heat transfer or work done may occur. The second point is the heat and work are boundary phenomena. They are observed at boundary of the system. Then the heat and work represent the energy crosses the boundary of the system. And last important point is the heat and work are path functions and hence they are inexact differentials. They are written as delta Q and delta W. In this session, we have studied the basic points related with the heat and work, means heat, sensible heat, latent heat, specific heat, work, heat and work as a path function, similarity between heat and work. For more details, you can refer the definition and end conditioning by Kurmi Gupta. In next video lectures, we will study the basic points related with the thermodynamics. Thank you very much for the patient listening.